So, welcome. First, I want to introduce myself. My name is Mark Hoffmann. I also work for Data in Motion. And the same as Jürgen, I am also involved in the OSGi working group. I'm also the project lead of the OSGi technology project. And today, I want to talk about a Vaadin whiteboard. We just heard the whiteboard from the WebSockets. And now I want to talk about Vaadin. What is Vaadin? Vaadin is a free Java-based web framework. Maybe all the guys that come from the Eclipse world may know RAP. And yeah, it's under Apache 2 license and has a server-based logic approach. It was developed from Vaadin Limited in Finland, and yeah, it's also got some commercial extensions and commercial support, additional commercial widgets that can be used in that framework. And currently, they have two different possibilities to create UIs. At first, they have a Vaadin Flow as a product, which is a back-end first approach. And this is what our talk is about. And that means that any UI code is written in Java. And there are a lot of UI widget libraries in Java you can use. And yeah, you have, in that sense, a back-end-based programming model. And in the end, what you need is a front-end. And this is then generated out of these back-end components at build time. Now, the second and newer product is called Vaadin Hilla. This is a TypeScript-based front-end. So you can program in JavaScript as you're used to, and then your Java callbacks and endpoints are created out of the front-end code, and you have then just implement these callbacks on the back-end side. The restriction is they currently have only a Spring-based backend, nothing else. Whereas with Vaadin Flow, you can use it in Jakarta EE or any other application. It's just a servlet. Okay, this is the first part. Now we have Vaadin as a product, and let's come to the OSGi Whiteboard. We just heard about it for the WebSockets approach. I just want to introduce you a little bit into the whiteboard approach. We have the classic listeners in OSGi, and we all know the classic listener-observer pattern, and we know it from maybe UI frameworks where we listen for input from text fields or button hits or something like that. And this classic listener approach has a tight coupling that is not always compatible to OSGi's dynamic approach, because this tight coupling leads to the tight coupling of dependencies as well. And in OSGi's dynamic, this can lead to situations where, for instance, observables must track the listeners, or on the other side, listeners must also track the observables. And yeah, this is not a good idea in OSGi. That's why there's a different solution for fixing that classic listener pattern. In OSGi, we just use the service registry as a so-called listener directory. And this is exactly what we can do. We can get all the listeners from the service registry. So an observer can ask the service registry at any time, give me all your listeners. And at the same point, we get informed about when listeners go away. So we always know what the current state is. And if we then use declarative services in the end, we don't have to deal with that. We have the callbacks and the declarative services handle that dynamics for us. Where do we use the whiteboard pattern in OSGi type save events? The event admin, for instance, WebSocket, Zoom. The Jakarta servlet whiteboard specification makes heavily use of the whiteboard. Jakarta RESTful web services, and now we also have the Vaadin Flow whiteboard. How does it look like? At first, an introduction. The Vaadin whiteboard is and will be no OSGi specification. It just builds on top of OSGi technology. The reason for that is very simple. We have just one product. There's no specification for the whole Vaadin stuff. It comes just from one company. So usually when we do a specification, then it should be possible that we have multiple implementations for WebSockets, for instance. You can use the WebSocket implementation from Jetty or even Tyrus. Here we only have one vendor that provides the implementation for Vaadin, and this is this company. In addition to that, the current implementation is based on Vaadin Flow 23. This is not the latest version. The latest version is 24, but it is based on Servlet 6. I will talk about this point later. The default implementation makes use of the OSGi HTTP whiteboard. So we build on top of existing specifications. And we make use of the OSGi programming model. We have to say, Vaadin already has an OSGi support. They have bundles. They also use the HTTP whiteboard, but that's it. In Vaadin, UI elements are called components, like in declarative services. So I call them Vaadin components. These are UI elements like views or layouts, something like that. And you have to program them as you're used to. It's a simple Java class, and you put some annotations on it, and that's it. And then the Java application comes, scans your code, and then registers all the components. So what we do, we want to use it as an OSGi service. In that sense, this implementation is an alternative to the existing OSGi implementation that is provided from Vaadin Limited. And we have to say that the existing OSGi license is currently a commercial license that they provide. Our stuff is open source. We have currently support for the latest Vaadin version in progress. Why? We need to wait till we have a OSGi servlet whiteboard specification that supports Servlet 6. Servlet 6 is not backward compatible anymore. It's a very special Java specification, and it makes a lot of work. As you all know, all the JavaX APIs moved to the Jakarta namespace, and for servlets, Servlet 5 was the first one in Jakarta namespace. And these guys took the chance to remove deprecated code from the whole Servlet API. And this all ended up in the Servlet 6 specification. That's why Servlet 6 is now not backward compatible. And in addition to that, it needs a servlet container servlet container runtime that runs with at least Java 11. So, and all this leads to a situation where we all need a new, a new jetty. And on top of that, we also need a servlet whiteboard specification that also supports the latest version. So, before we talk about the good sides, I want to talk about the bad sides. Because one problem is Vaadin cannot handle dynamics very well. It comes from a static world, a monolithic world. So what they do, as I already told, they take a monolithic application, scan the annotations, register everything, and they do that as on deployment time when you deploy the servlet, and then your application's up and running. This leads to the situation that if you have a Vaadin application running, then you only have one. This one is your application, and you cannot create another one. So dynamics is not their style. And so it's hard sometimes to add new UI components during runtime, because we have to register the new component at the registries. We cannot scan everything when a new bundle arrives. This is, we could do that, but it's very bad. And also we have to create the front-end code at build time. So it might be possible that we have the back-end code dynamically loaded very well, but we don't have any JavaScript code. We also have some timing issues from time to time because of the registering. Declarative services are very fast, and sometimes it can happen that the services, your Vaadin components, UI components, are registered at a whiteboard before they are registered at a Vaadin root registry. That means that the Vaadin servlet cannot find the UI component if you type the right URL. And this is currently a problem, and we are working on that currently hopefully for the next version that we finally solve this problem. This occurs not very often, but from time to time this can happen. One bad thing is the front-end build is not modular. As I already told, if I have a new component, I have to build the whole dependencies, because in Vaadin, each widget jar contains also the JavaScript code. JavaScript snippets for this UI element. So the Vaadin front-end build collects everything and then builds something. Yeah, OSGi is, as I mentioned, already supported in Vaadin, but not really. So currently they don't have OSGi support in the latest version because they don't have a developer that supports OSGi. So we end up with having OSGi manifest that's working very well, but they don't have really OSGi support currently. Let's come to the features. Vaadin components, UI elements, can be OSGi services. Either declarative services or programmatically registered services, doesn't matter. And if you are a Vaadin developer, you can also use the ordinary Vaadin annotations as you're used to. For instance, route or page title. And we also added some component property type annotations to make the configuration in OSGi easier, just like we know it from JuxRS whiteboard or the servlet whiteboard, or hopefully the WebSocket whiteboard. And we have build support. Vaadin only builds their UI usually using a Maven plugin. So you have to do a Maven build to get the front-end code. They Stefan, they have Gradle support, but not really. It worked not very well. So we created Stefan created some patches to a little bit, make the generator a little bit more modular. And so we had the possibility to create an own build support for BNE tools to build the front-end code. What we do, usually, we build the front-end code in an OSGi fragment. A fragment is not a bundle, it's just an addition to a bundle, so we can keep all the Java code in our bundle, and the front-end code is just attached as a fragment. So we don't pollute our bundle with JavaScript code. And because we are using the HTTP whiteboard, now it's possible to host many Vaadin applications at many context routes as we like it. So we have full control where such a Vaadin application should run. Let's take a look at the simple Vaadin component. We see here the route annotation, which comes from the Vaadin API, and also the page title. And in line 3, we start with the component as a prototype class, the same like many other whiteboards. And then we have our component property type annotation that just creates some service properties that say, hey, I am a Vaadin UI component. And then we also use the activate callback for constructor. And then we have our UI code. This is the Vaadin UI code. So very simple. And also this class, the horizontal layout, is also UI code from Vaadin. And then we can have something like this. Vaadin already provides existing layouts, something like the application layout, which consists of different areas. We have here this badge and main area and some controls and stuff like that. Profile area with avatar, with configurable avatars, and you can place your submenus in it, like logout or settings for your profile. We have a navigation area here as a flyout, just when we pushed it, small button here. And we can place the navigation in it, and we have a master details selection handling means when I click here, then this front-end element will be activated. So we don't have to deal with that. This layout handles everything for us. And usually we also have a content area. So now we have seen how we can deal with front-end code. And now let's go a little bit deeper into the front-end building process. And as I already mentioned, the default process building such applications is, in Vaadin, you have to use Maven. And you have several components that contains some JavaScript code and JavaScript snippets like the widgets. And you need all the dependencies in the Maven build to get all the JavaScript code, and this is all grabbed together and copied out of the jar into a build location. In addition to that, you can also customize your layout, your UI a little bit with CSS and other JavaScript stuff. And this code is also to be copied into the build location, and then they execute an NPM build. And in the end, you get a single-page application that is then packaged into a folder and then packed into a jar. This is how it usually works. In OSGi, we changed that a little bit. Because we have no monolithic build path. our front-end build needs the right dependencies. So usually when you build a Vaadin application, all the elements are packed together. It's a full-featured UI. You get the full-featured JavaScript code for all the widgets that are available in a default dependency tree. With our build, this is a little bit different. BND, we use BND to resolve the dependency of a Vaadin application. If you have a Vaadin application that consists of this application layout and just a button, then we only get the JavaScript code for the application layout and the button and the corresponding dependencies. And we can use that with the OSGi resolver in BND, very simply. And so the npm build just builds what really is needed for our front end. And yeah, and we can place the front end code in any jar we like. We just use the BND generator extension, and yeah, we can do it twice, 2 jars, or whatever. And this BND generator works with Maven and Gradle and also in the IDE, especially in the Eclipse IDE. So how does a snippet look like? It's very simple. We have ordinary stuff in here. We say, OK, we have here a fragment, and the fragment host is our Vaadin example bundle, and we have to include this folder. This is the folder where the Vaadin framework looks for the JavaScript front-end code. Yeah, we have to create a build path and build dependencies. And this is also important. We have to say depends on in BND so that we ensure that our host bundle is really built before we generate the code. And this is then just our generation instruction. We use exactly this generator, and it should build our output in this folder. So then we define our run requirements, and with that, we just have to press the resolve button, and everything that we need comes into play. Beside the whole front-end build, there are also, already mentioned, customization possibilities in Vaadin to make it your own UI. You can customize the CSS styling. You can create whole themes for complete application that applies to everything that runs under that setup. You can also create your own widgets. I will show you an example later. And you can also create your own layouts. We have seen the application layout. If you need, for instance, a status bar underneath, then you can just extend the layout and create your own ones. How do we deal with that in OSGi? We have to know that Vaadin expects certain UI elements in certain folders, and these folders are predefined currently in Vaadin. So this is important to know in the build. I can show you some of these extensions, and you only have to know that you have to package these folders in your jar. You don't have to forget that. And for instance, resources like images or static HTML pages are expected in a folder called resources. You can just put it in your jar, place your images in it, and package it. Front-end related stuff is expected in a front-end folder. So if you, for instance, have customized widgets or something like that, or themes, then you have to use this folder called frontend in your jar. Okay, then let's go in the practical section. you can try it out. You just need some artifacts, the Vaadin Whiteboard implementation in the API. It's available on Maven Central. And for the build support, for the generation support of front-end, you just have to use the generator bundle. And we also have a GitHub project. So I said the latest version is 23. We have 2 special branches for that because we also have an implementation based on the former version, long-term version, Vaadin 14, which still has support. That's why we also have the existing tree for that. So then let's look to the demo project. Demo project is very simple. We have one bundle that contains the Java code. Then we have a second bundle that contains the JavaScript code. We use an application layout. We will see a custom widget example, the build process, and we will also see the launch setup. So first, what we also have in Vaadin, you initially started an application. You get always an offline page like this. You can also customize this page. So this is, we see there's no running application at the moment. So, and here we have the code. So this is the main application, the application layout code. This code was taken from the Vaadin example. There's some basic tutorials, and they provide such code in their examples, and we just took that as starting point. And it is based on an application layout we've seen before. And I think we should start the application to see how it looks like. So what we have done, nothing else than just a configuration. We just configured our application as whiteboard, as a servlet whiteboard under the context root 23. And this is what we see here. If we now press reload, then we should see the whole application. So this is the application layout. We have the flyout here. And we have 3 different components with this doing something. So the application layout class we've seen was just the basic pattern for all this, the basic structure. And beside that, we have an ordinary OSGi service here that is used. And then we have the hello world view. This one says hello world. And this is the simple code. We can consume our foreign services, and we just have to define the ordinary Vaadin stuff. So this can be taken from any Vaadin documentation, example, whatever. And we only have to place our OSGi component annotations on it. Yeah, and then we just create a simple text field and a button and a click listener that creates a notification. And if we say hello, then we see the notification. The about is just a simple label. But the third part is an example for a map view, which is a custom widget. It uses OpenStreetMaps and JavaScript OpenStreetMaps components. And you can define something like that here directly in the Java code using annotations. It says, OK, please take from NPM leaflet in version 1.9. This is very important for the build, because when we create the build setup, then these annotations will be taken, and in the NPM build, the corresponding dependencies will be downloaded and also then used in this code. And the same applies to the CSS, and here we take the TypeScript component in our code. And Vaadin also has a connector to the JavaScript code, which then calls just a JavaScript function from this leaflet map called setView, where we just provide our geographic coordinates. So, and we end up with something like that. And we also can use this. And here in these folders, we can see that we have the front-end code. Here we have the additional component that does the TypeScript stuff that was developed from our side. In addition to that, we also have some theming support so that we can customize the colors and images and stuff like that. And the same applies to the resources folder. And yeah, custom images like our logo here. So, just as a short demonstration. Yeah, what comes next? We currently try to move the build process from a pure BND Gradle setup to a Maven build. We think it's easier for the community, especially because the whole Vaadin project also builds upon Maven, so we will also use it. And the next steps will be we are moving forward to Vaadin 24. As already said, we wait for the Servlet 6 support. And if we have then Jetty for that, then we will go to migrate everything to the newest version. Together with that, we want to make Vaadin more modular. Currently, the registries there are very static, but the API is not that bad, so we can make their registries a service. So this makes it possible that we also solve the timing issues between the routing I described before. We also want to improve the build process. Currently, as I said, they scan for annotations. In OSGi services, we have the possibility to provide service properties. And we can make this work, gather the information for the front end during runtime at one point. And we can also do that in BND tools during development time. So we don't have to wait until we have to build something. During development time, if we do something and place an annotation, we can use BND to directly say, okay, I have to copy some code over there. And then we can also run the generator, and then we can have already the new front end in place. So, yeah, that's it for the moment. I would say thank you. And yeah, any questions? Nope. Good. Then I would say thank you and have a nice evening.